Hello students, I am Dr. Manju Gupta, Department of Chemistry, St. Aloysius College. Today I am going to start second unit of organic chemistry, that is alcohols and phenols. First we will discuss general introduction and methods of preparation of the alcohols. There are different class of organic molecules which can contain hydroxyl group like alcohols, phenols, enols and carboxylic acids. In alcohols, OH group or hydroxyl group is attached with the sp3 hybridized carbon. In phenol, OH is attached with the benzene ring carbon, that is sp2 hybridized. In enol, OH group is attached with the alkene carbon, and in carboxylic acid, hydroxyl group is attached with the carbonyl group. Since in all the four classes of molecules, the OH group attached with different type of carbon atom. That's why the chemistry of these four different functional groups are different. We can consider alcohols as alkyl derivative of water. That means one of the hydrogen of water is, if it is replaced by alkyl group, then water is converted into alcohol. So they can be considered as the alkyl derivative of water, or the alcohols are considered as hydroxyl derivative of alkane when one of the hydrogen of alkane is replaced by the OH group. For example, in methane, one of the hydrogen is replaced by OH group. So methane is converted into methanol. The three members of alcohol series, three main members. Methanol. Methanol is obtained by wood, so it is known as wood alcohol. It is highly toxic. Second one is the ethanol. Ethanol is obtained by grains by fermentation, so it is known as grain alcohol. And ethanol is used in alcoholic beverages. The overuse of ethanol can lead to liver damage. Third most common alcohol is the 2-propanol. 2-propanol is many times used in the lubricating machines for the lubrication. So it is known as rubbing alcohol. It is less toxic, and it has ability to kill the germs. That's why it is used in the formation of sanitizer. Now we come to the IUPAC nomenclature of the alcohol. There are certain rules for the nomenclature of the alcohols. First rule, in the given compound, first we have to find the longest carbon chain containing the carbon with the OH group. Second, that longest chain is considered as the parent alkane chain. Drop the E from the alkane name and add, in place of E, add all. Third rule, number the chain giving the OH group the lowest possible number. That means numbering will start from the side where the OH group is present at the nearest. And last rule, number and name all substituents and write them in alphabetical order. For example, in this particular compound, first we select the longest carbon chain. This is the longest continuous chain that contains the hydroxyl group. This chain will select as the parent compound. This chain has 4 carbon. All the carbon are connected with the single bond. So we can consider this alcohol is derivative of butane. The parent compound is butane. Second is the numbering. From this end of the chain, numbering will start from this end, because from this side the OH group is present to the closest of the number. So begin the numbering from here. 1, 2, 3, 4. At the second position, OH is attached, and at the third position, methyl group is attached. 2 substituents are there, hydroxyl and CH3. For hydroxyl, we will use OL, all, and third position is methyl. The IUPAC name will be 3-methyl 2-butanol or 3-methyl butane 2-ol. Some other examples of nomenclature: For this compound, it has 7 carbons, 1, 2, 3, 4, 5, 6, 7. At the third position, there is hydroxyl group. It is the derivative of 7 carbon chain, that is heptane. At third position, there is OH, so its name will be 3-heptanol. Another example, the molecule is the same with 7 carbons, and at the 5th carbon there is one substituent CH3, and in between the 6th and 7th carbon there is double bond, so it is the derivative of alkene. We have to name the CH3 group, methyl substituent, alkene and OH. Its name will be 5-methyl. At the 6th position there is double bond, 5-methyl, 6-heptene, 2-ol. Next example. This is the derivative of cyclohexanol, in which at the third position 2 methyl groups are attached. So its name will be 3,3-dimethyl cyclohexanol. When the OH group is present on the first position, sometimes it is not necessary to write the number. Next, with the 5th position, 2 methyl groups, other than 2 methyl groups, one double bond is also present. So it will be the derivative of cyclohexene, and its name will be 5,5-dimethyl cyclohex 2-enol. When double bond and OH both are present, then we can give the combined name en plus ol, enol. Next part is the classification of alcohols. Alcohols are classified on the basis of carbon from which hydroxyl group is attached. We have to look the carbon that is attached with the OH group. If this particular carbon has no other carbon, then the compound or alcohol will be methyl alcohol. If it is attached with only one carbon atom, then it will be primary alcohol. If it is attached with 2 carbon atoms, 2 alkyl groups, then it is secondary alcohol. And if all the 3 valencies of hydrocarbon other than OH are replaced by alkyl groups, then it will be tertiary alcohols. Primary alcohols, the carbon which carries the OH group only attached to one alkyl group, like ethanol, 1-propanol, or 2-methyl 1-propanol. These are the few examples of primary alcohols. Secondary alcohols. In secondary alcohols, the carbon with the OH groups attached is joined directly to 2 alkyl groups, and these alkyl groups may be the same or different. For example, 2-propanol, in which the 2 same methyl groups are attached with the CH. 2-butanol, at one side CH3, at one side C2H5. Pentane, 3-ol. Tertiary alcohols. In tertiary alcohols, the carbon atom holding the OH group is attached directly to 3 alkyl groups, which may be any combination of same or different. All the 3 may be the same, all the 3 may be the different. These are the methods which can be used for the preparation of alcohols. First method is the hydrolysis of alkyl halide, hydration of alkenes, catalytic hydrogenation. Alcohols can also be prepared by Grignard reagents, reduction of carboxylic acid, reduction of acid chlorides and esters, reduction of epoxides, oxymercuration, demercuration or reduction of alkenes, hydroboration, oxidation of alkenes. We will discuss these methods one by one. First method is by the hydrolysis of alkyl halide. Alkyl halide, that means RX. Hydrolysis, that means reaction with water in presence of NaOH or KOH. So we can say alkyl halides reacts with aqueous NaOH or aqueous KOH and converted into alcohols. For example, reaction of ethyl bromides with aqueous NaOH, formation of ethanol and NaBr. If we discuss the mechanism of the reaction, in the mechanism, first the reactant or the base or the catalyst, that is NaOH, ionization of NaOH, and it produces Na plus ion and OH minus ion. OH minus negatively charged, which act as nucleophile, and it will attack on the electrophilic carbon of the alkyl radical. In the first step, there is the formation of transition state. As the transition state dissociates, there is the formation of product, which is alcohol. So by the hydrolysis of alkyl halide, there is the nucleophilic attack on the electrophilic carbon. Second method is the hydration of alkene. Hydration of alkene, that means addition of H2O on the carbon double bond carbon. The addition of water to an alkene in the presence of catalytic amount of strong acids like H2SO4 leads to the formation of alcohols. In presence of sulfuric acid, water molecule will be added to the double bond of the alkene. This reaction proceeds via a standard carbocation mechanism and follow the Markovnikov rule of addition. First step of mechanism. The first step of mechanism, since the reaction is taking place in the strong acidic medium, that means H plus ions present as the catalyst. The H plus ions is attracted towards the pi bond or electron rich center of the molecule and attack on the pi bond and can form a bond with the one of the carbon. And the other carbon will have the positive charge, so it is converted into carbocation. So the first step is the formation of carbocation. Second step of the mechanism involves an acid-base reaction between the water molecule and carbocation. Carbocation has positive charge, and the OH negative part of the molecule, or with the help of the lone pair of electrons of water molecule, it can form a bond with the carbocation and produce protonated alcohol, or it is known as oxonium ion. When oxygen is positively charged, that is known as oxonium ion, or since it has extra proton, so it is known as protonated alcohol. Last step, since the oxonium ion stabilizes by losing a hydrogen ion, with the results in the formation of alcohol. This protonated alcohol release H plus. Since H plus in the first step it was used as the catalyst, so in the last step it was regenerated. So the mechanism involves three steps. First step is the formation of carbocation. Second step is the acid-base reaction of water molecule with the carbocation. And third step is the removal of hydrogen ion or hydrogen proton from the protonated alcohol and formation of alcohol. Third method that is used for the preparation of alcohol, that is most important, and most of the times it is used for the laboratory preparation. It is used prepared by the use of Grignard reagent. Grignard reagent is the most popular reagent of organic chemistry. Its general formula is RMgX, and it is prepared by the reaction of metallic magnesium with organic halide, alkyl halide. Here you can see the reaction of methyl bromide with magnesium atom and formation of the Grignard reagent. Here in this molecule there is the charge separation. CH3 carbon is negatively charged and magnesium is positively charged. In this reaction, formula is RMgX. Generally, ethers are used as a solvent to stabilize the complex Grignard reagent. Alkyl iodides are the most reactive substances, and fluorides generally do not react because the reaction must be explosive in the nature. Formation of Grignard reagent may be possible by primary, secondary, and tertiary alkyl halides. Grignard reagent act as nucleophile towards the carbonyl compound, carbonyl group. Always with the Grignard reagent, two steps are involved. First step is the addition step and second step is the hydrolysis. In carbonyl carbon, carbon is the positively charged, that means it is electrophilic in nature. The nucleophilic center of Grignard reagent attacks on the electrophilic carbon atom, and in the first step there is the formation of addition product or adduct. The alcohol and in the second steps the addition product or adduct undergo hydrolysis and convert it into product. This is the two-step sequence gives an alcohol as the isolated product. In the alcohol, the carbon comes from the carbonyl compound and the new carbon-carbon bond is to the alcohol carbon bond. This is the summary of the reaction of Grignard reagent with carbonyl compounds. When Grignard reagent reacts with formaldehyde, it forms primary alcohols. When it reacts with any other aldehydes, it forms secondary alcohols. When Grignard reagent reacts with any ketones, it forms tertiary alcohols. First, reaction of Grignard reagent with HCHO or formaldehyde in the presence of diethyl ether. In the first step, nucleophilic center of Grignard reagent attacks on the electrophilic carbon. Movement of double bond towards the oxygen. First step is the formation of addition compound or adduct, and after that it undergoes hydrolysis and form primary alcohol. Product is primary alcohol. This is the example of the formation of primary alcohol. Here cyclohexyl chloride is used. Cyclohexyl chloride react with metallic magnesium and form cyclohexyl magnesium chloride in the form of Grignard reagent that will attack on the formaldehyde. In the first step form addition product, and after hydrolysis it forms a primary alcohol. Second, Grignard reagent reacts with aldehydes. When it reacts with aldehyde other than formaldehyde, one alkyl group comes from the Grignard reagent and another alkyl group already present in the aldehyde molecule. So with the carbon that is attached to the hydroxyl group must contain two alkyl groups, so it will result in the formation of secondary alcohol. First step is the same, attack of nucleophilic center of Grignard reagent to the electrophilic carbon in presence of ether, formation of adduct. Adduct undergoes hydrolysis and form secondary alcohol. This is the example of formation of secondary alcohol. Here we are taking alkyl bromide. Alkyl bromide react with acetaldehyde. First addition product is formed, and second there is the formation of secondary alcohol. Third, Grignard reagent can also react with ketones. Now, three alkyl groups are involved in the reaction. One alkyl group is present in the Grignard reagent and two alkyl groups present in the ketones. So, with the carbon that is attached with the OH group, it must bear three alkyl groups and it will result in the formation of tertiary alcohols. When nucleophilic center of Grignard reagent attacks on the electrophilic carbonyl carbon, it forms addition product, and addition product after hydrolysis converted into tertiary alcohols. This is the example of formation of tertiary alcohols. So only the Grignard reagent reacts with the same class of compounds, that is carbonyl compounds, but with the different carbonyl compounds, it gives different type of alcohols. If we want to prepare primary alcohol, then the reagent will be formaldehyde. If we want to prepare secondary alcohols, other than the formaldehyde, any of the aldehyde can be used. And for the preparation of tertiary alcohol, the reaction involves reaction of Grignard reagent with any of the ketone. Thank you.